Invisibility, fantasy or our future? Scientists and researchers all over the world have made lots of important discoveries in the field of metamaterials. Metamaterials were first hypothesized by Victor Scalago, who postulated the idea of left-handed materials in 1967, where left-handed materials is a material that does not obey the right-hand rule that many of you will be familiar with, allowing an electromagnetic wave to convey energy, or have a group velocity, in the opposite direction to its phase velocity. By manipulating these new materials, researchers have found ways to bend light such that it passes round an object as if it wasn't even there. Now the hunt has been to find a metamaterial which will do this for visible frequency range, so visible light will pass around an object, making it appear as if it is invisible. A metamaterial is a material that obtains its properties from its structure instead of its composition. The main reason researchers have been interested in metamaterials is so that they can create materials with a negative refractive index. The refractive index of a material can be described by an object's permittivity, described by epsilon, and permeability, described by the letter mu. For a material to have a negative refractive index, both its permeability and permittivity must be negative. Some naturally occurring materials, such as gold and silver, have already been found to have a negative permeability, and a negative permittivity can be created by setting up a specific structure of conducting and capaciting loops of a wire with current running through it. In this sense, the ring acts as a conductor, and the open section as a capacitor. The ring as a whole can then be seen as an atom, just on a much larger scale, and hence acts as an LC circuit. When an electromagnetic field passes through the ring, a current is induced in the generating field, which is perpendicular to the magnetic field of light. The negative resonance results in a negative refractive index. This method of creating negative refractive indexes has found to actually been very successful in 1999. Unfortunately, this method does not seem to be very useful for visible light, only microwave, due to the fact that in order for the physical structure of the atoms to affect its optical properties, the gaps between each atom must be smaller, much smaller really, than the wavelength of electromagnetic radiation that it interacts with. Although research is currently happening at universities across the world, including Imperial and Edinburgh, to try and see if these issues can be overcome, unfortunately, to this date, there has not been too much progress. To this day, the majority of the research involved in this has been conducted by military bodies, such as the US, who has been recently trying to create a drone which has the potential to be completely invisible, although hopefully in the future communication companies will become more interested.